Good morning, students. How are you? I hope all of you are well. Last time we have discussed about the lines in 3D geometry, and now today we have to discuss about the plane. We have to form the equation of planes. So first of all we have the plane. What is plane? A surface is said to be plane if it has length and breadth only. The extremities of a surface are lines. The surface lies evenly with the straight lines itself. And now equation of a plane. How the equations of a plane can be find? If it is perpendicular to a given direction and distance from the origin is given. It passes through a point and is perpendicular to a given direction. It contains three non-collinear points. It contains two intersecting lines. It contains two parallel lines. Equation of plane in intercept form. जैसे हमारे पास लाइंस की वैरायटी थी लाइंस फाइंड करने के लिए, वैसे हमारे पास प्लेन्स के लिए है. So first of all we have the equation of plane in normal form. In normal form we have given the distance from origin to the plane, that is d. And now you have to consider that is the plane, and ON, that is the distance from origin to the plane, that is d. And n cap is the unit normal vector along ON, and therefore this ON is the normal vector to the plane, and this ON vector is equal to d into n cap, because distance from the origin to the plane is d, that is the magnitude of ON, and n cap, that is the direction of ON. It means ON vector is equal to d dot n cap. And now here P, X, Y, Z, whose position vector is R, is any point on the plane. This is the general point. जैसे हम लाइंस में P, X, Y कंसीडर करते थे, ठीक है, वैसे हम जनरल पॉइंट हम कंसीडर कर रहे हैं प्लेन पर. And when we have to join this NP, and this NP vector is perpendicular to ON vector. When the two vectors are perpendicular, their dot product is 0. It means NP vector dot ON vector is equal to 0. And now NP vector. What is NP vector? That means the position vector of P minus position vector of N. Position vector of P is vector R and position vector of N is d dot n cap. And therefore NP dot ON vector is equal to 0 is R vector minus d dot n cap dot d dot n cap is equal to 0. And when we have to simplify this, d, that is a constant distance, divided by d, we get R minus d n cap dot n cap. And therefore R dot n cap minus d n dot n cap is equal to 0. N dot n cap, that is the dot product of unit vector, its value is 1. And therefore we get R dot n cap is equal to d, which is the vector equation of the equation of plane. Is it clear? And now we have to convert the vector equation in Cartesian form. Here we have to consider P, X, Y, Z, that is any point on the plane. It means OP vector, that means the position vector of R, is xi plus yj plus zk. And LMN, that is the direction cosines of a unit vector. And therefore n cap is equal to Li plus Mj plus Nk. And now R dot n cap is equal to D, that is converted into xi plus yj plus zk dot Li plus Mj plus Nk. Taking the dot product, it becomes Lx plus My plus Nz is equal to D, which is the Cartesian equation of a plane. In this, L, M, N are the direction cosines of the normal to the plane. And D is the distance from origin to the plane. And now example C. Find the vector equation of a plane which is at a distance of 7 units from the origin and normal to the vector, normal to the plane is the 3i plus 5j minus 6k. And now the normal vector, that means n vector is 3i plus 5j minus 6k, but in normal form we have r dot n cap is equal to d, and that's why we have to find n cap. N cap you have to find, that is n vector divided by magnitude of n. N vector is 3i plus 5j minus 6k and its magnitude is 3 square plus 5 square plus 6 square its root, that is equal to root 70, and therefore n cap is 3i plus 5j minus 6k divided by root 70. Is it clear? And now the equation of plane with position vector r is r dot n cap is equal to d. And now substituting the values here, vector r dot n cap, that means 3i plus 5j minus 6k divided by root 70 is equal to 7, which is the required vector equation of the plane. And now if we have to convert into Cartesian form, तो हमें क्या करना होगा, वेक्टर r के स्पेस पर xi plus yj plus zk सब्स्टिट्यूट करेंगे. Okay, then you will get the equation. Take the dot product and you will get the equation in the Cartesian form. जैसे हमने जनरल वे में किया था अभी, वैसे आप इसको चेंज कर सकते हैं. Is it clear? And now the equation of a plane passes through a point whose coordinates are x1, y1, z1, a, and is perpendicular to a given direction, that is n vector. And now that means in this case we have given the normal to the plane and a point. Normal to the plane is n vector and the point is x1, y1, z1. And therefore normal to the plane is n vector, that is ai plus bj plus ck. And position vector of A, that is vector A, is equal to x1i plus y1j plus z1k. And P, that is any point on the plane, with position vector, that is vector R, is equal to xi plus yj plus zk. And therefore we have this AP vector. This AP vector is perpendicular to n vector, क्योंकि P और A हमारे पास क्या है, प्लेन के ऊपर पॉइंट है, A गिवन पॉइंट है, P हमने जनरल पॉइंट सपोज किए, और जो n वेक्टर है वो प्लेन के क्या है, परपेंडिकुलर है. जब ये प्लेन के परपेंडिकुलर है तो ये हमारे पास AP के भी परपेंडिकुलर होगा. इट मीन्स AP dot n vector is equal to 0. It means AP vector, that is the position vector of P minus position vector of A. That means R vector minus A vector. And therefore we get R vector minus A vector dot n vector is equal to 0, which is the vector equation of a plane passing through a point and perpendicular to the given direction. And now we have to convert into Cartesian form. In Cartesian form, we have to write vector R is xi plus yj plus zk, and in space of R vector, and vector in space of vector A, we have to write xi, x1i plus y1j plus z1k dot n vector is ai plus bj plus ck. In n vector, we have given the direction ratios A, B, C. And now you will get x minus x1 into I cap plus y minus y1 into j cap plus z minus z1 into k cap dot ai plus bj plus ck. Take the dot product. You will get a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. On simplification, we get ax plus by plus cz plus d is equal to 0, where d is equal to minus of ax1 plus by1 plus cz1, which is a constant term. Is it clear? And now the equation of a plane passes through a point and perpendicular to a given direction. Now we have to define this equation of a plane passing through a point whose position vector A is given and perpendicular to the vector n is r vector minus a vector dot n is equal to 0. And the Cartesian equation, that is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. Here we have c. Okay. And now the equation of a plane passing through three non-collinear points. Here we have the three non-collinear points. First is P. P is the general point. First is R, whose position vector is A. Second is B, whose position vector is B. And third is T, whose position vector is C. The plane passing through three non-collinear points. And what is the normal to the plane? Normal to the plane is RS dot RT. That is perpendicular. RS and RT vector. RS vector and RT vector that lies on the plane. And the cross product of two vectors is always perpendicular to the plane. And that's why RS cross RT is perpendicular to the plane containing 3 points R, S and T. And now we have to consider any point P whose position vector is R. And the equation of a plane passing through the point R and perpendicular to the vector RS cross RT is vector R minus A dot RS cross RT is equal to 0. ये अभी हमने जो लास्ट इक्वेशन की थी passing through a point and perpendicular to the vector, that is R minus A vector dot n vector. यहाँ पर हमने n को रिप्लेस कर दिया RS cross RT से. That is the equation of a plane. And now replace this RS and RT. RS means position vector of S minus position vector of R. That means B minus A vector. And RT vector, position vector of T, that is C. Position vector of R, that is A vector. And therefore, in equation of a plane passing through three non-collinear points is vector R minus A dot B vector minus A vector cross C vector minus A vector is equal to 0. Is it clear? This is the. And now, if the 3 points lies on the same line, then there will be many planes that will contain them. जैसे हमारे पास क्या है, आपकी बुक का जो बाइंडिंग वाला पेज है, जहाँ पर वो बुक बाइंड होती है, उस लाइन के ऊपर अगर हम 3 पॉइंट्स कंसीडर करें, क्योंकि वो एक ही लाइन के ऊपर लाई करते हैं, तो वहाँ पर बहुत सारे पेजेस हमारे पास करते हैं, यानी कि बहुत सारे प्लेन पास करते हैं। और ये जो हमारे पास इक्वेशन है प्लेन, that is always passing through 3 non-collinear points. Is it clear? And now the Cartesian equation, we have to convert it to Cartesian. That means x, y, z, that is a general point, and x1, y1, z1, x2, y2, z2, and x3, y3, z3 are the coordinates of the 3 points. Rp vector means x minus x1 into I, y minus y1 into j plus z minus z1 into k. And rs vector, that is x2 minus x1 into I, y2 minus y1 into j, and z2 minus z1 into k. Similarly, r3 vector, rt vector, that is x3 minus x1 into I, y3 minus y1 into j, and z3 minus z1 into k. That means substituting these values in the vector form. What is vector form? That is r minus a dot rs cross rt, that is the scalar triple product. And scalar triple product we have to find by the determinate form. That means we get x minus x1, here y minus y1, here z minus z1. Then x2 minus x1, y2 minus y1, z2 minus z1, and x3 minus y1, x1, y3 minus y1, and z3 minus z1. Here is the point y minus y1 and z minus z1. Okay. And now the equation of a plane, find the equation of plane that passes through 3 points 1, 1, 0, 1, 2, 1, and minus 2, 2, minus 1. Given points. So first of all, we have to find this one. That means first of all we have to check 3 points are collinear or not collinear. Take the determinants of this 1, 1, 0, 1, 2, 1, and minus 2, 2, minus 1. On expanding this, you will get minus 5, which is not equal to 0. It means the 3 points are non-collinear points. And the plane passes through the 3 non-collinear points. That is the equation of a plane passing through 3 non-collinear points, x minus x1, y minus y1, z minus z1. Here you have to see y minus y1, z minus z1, x2 minus x1, y2 minus y1, and z2 minus z1, x3 minus x1, y3 minus y1, and z3 minus z1, and its determinant is equal to 0. Just simply substituting the values of x1, y1, z1, x2, y2, z2, and x3, y3, z3 in this determinant, and then expand this, you will get the equation of a plane. It means determinant of x minus 1, y minus 1, z 0, 1, 1, minus 3, 1, minus 1 is equal to 0. Now expand this, and you will get the equation of a plane, that is minus 2x minus 3y plus 3z plus 5 is equal to 0. That means you can write 2x plus 3y minus 3z is equal to 5. That is the Cartesian equation of a plane. Is it clear? जब तक हमारे पास मेंशन नहीं होता कि आपको वेक्टर इक्वेशन फाइंड करनी है, तब आप वेक्टर इक्वेशन फाइंड कीजिए, अदरवाइज आप कार्टेशियन इक्वेशन कीजिए. ओके. अगर वेक्टर भी गिवन है तो आप उसको कार्टेशियन में चेंज करके कार्टेशियन की तरह से वर्क करोगे तो ज़्यादा इजी हो जाएगा. Is it clear to everyone? Thanks and have a nice day.